Hi everyone, I'm Luis Delgado from the University of Westminster, and I will present MultiModX projects. MultiModX is an exploratory research project reaching TRL2, and it just finalized a couple of months ago, so I'm going to do a very high-level overview of the main findings and approaches. So as we are all discussing here, we want to make multimodality, we want to make passengers to fulfill their journey door to door, and it starts with the strategic definition of the network. So what are the schedules, what are the different options that passengers have to fulfill that? And we are doing that months, years before the day of operations, and the goal is to have a coordinated and functional network that allows passengers to switch between modes in an efficient way. Then we have the day of operations, and as they say, when things hit reality, then things go wrong. There is many points of failure, so what we have to do is to have measures that allow to have a smooth mobility. And by that we mean mechanisms that support the multimodality, so that if the systems on surface access or the airports or the flights have any kind of delay or disruption, the passenger still can find their journey through the day. And something that is tricky is that usually we don't have one network, we may have several, and we are working here in research, but also from an industrial point of view, you can have different ways to manage your system, different schedules for the airlines, different timetables for the rail operators, for example. And likewise, there is different things we can do tactically. We can have from very reactive, fast track lanes at the airport for passengers with multimodality, to the replanning of operations by rerouting passengers to different modes in a more futuristic scenario. So that led us with an issue, that is that we need a set of tools and a framework to evaluate these different approaches so that we can assess with different performance indicators how they behave. Because there is always going to be trade-offs, so we cannot say that one approach is better than another. We have to be able to have a more broad view, and everything is underpinned by the passenger on their door-to-door journey. So we need passenger-centric view of that. And this problem is what MultiModX was trying to address. So the project was led by Bauhaus. Then we have UIC as partners, the Technical University of Dresden, Nomon, ARC, and the University of Westminster. We developed 3 solutions in MultiModX. The first one, that it's called Solution 400, was looking into the synchronization of schedules between trains and flights, and between flights and between trains, to try to have a better connectivity on the system. Then we have Solution 401, which was dealing more with the replanning of operations in case of disruptions. So we were sitting more close to pre-tactical operations when we have big disruptions, how to replan the network. And finally, we have Solution 399, which is the performance framework and the evaluator. And something that I want to stress today is that Solution 399, everything we have developed is open source, so it's available to the community, and we would like people to reuse it and to comment and to help us to improve it in the future. Very, very high overview. In Solution 399, we have a catalog of passenger-centric indicators and these open source tools to evaluate the plan and the realization of the networks. In Solution 400, as I said, we optimize the rail timetables and the schedules. And Solution 401, it does coordinated recovery strategies in case of disruptions. For Solution 400, we saw that in the case studies we did, which is intra-Spain mobility, adjusting the rail timetables and the flights in a window of plus minus 10, 20 minutes, you can improve a lot the connectivity at the hubs and reducing the door-to-door time for passengers up to 20%. And in case of disruptions, with Solution 401, we were able to estimate that the number of stranded passengers was reduced over 70%, which means that all passengers wouldn't have had a path to reach their final destination, and they are found alternative options. So let's look a little bit with more detail into the multimodal performance framework. The first thing, as I said, it was to develop a catalog of indicators, which is passenger-centric, because the important thing here is that we need to capture the experience and the passenger reaction to the system on their door-to-door journey, and we wanted it to be open. So for that, we have provided in that website that you can access with the QR code, and we have all the indicators there listed. So we focus on different performance areas and indicators, like from operational efficiency to capacity or interoperability. And as you can see by the examples of some of the indicators, all of them are, or most of them are passenger-centric, considering that total journey. And something that we did that I think it's quite interesting is that we analyzed these indicators that can be challenging, can be new from the community in the framework of CSAR. So we did a mapping between these new indicators and the ones that exist in the performance framework, and that's what you can see there on the right-hand side. Level ones are indicators within the performance framework that some of them could relate with multimodality, even if in a loose way, such as, for example, on-time performance. While then we have level 3, which is very futuristic indicators trying to capture the whole door-to-door experience of the passengers. And level 2 were indicators that were at least modeled by some of the projects that we have been presented today. And from those, then we did an analysis of which ones will be candidates to be promoted to level 1. Once we have these indicators, we develop a set of tools to be able to assess multimodality. And we start with the evaluation of planned networks. And by that, we mean that you have the schedules, you have the rail timetable, you have the information about the infrastructure connectivity, so in which airports the passengers can change between flights and trains, how long it takes, minimum connecting times, and things like that. So that allows us to characterize the supply and the demand in terms of mobility. And then we evaluate it from a passenger-centric perspective. So to understand what we did, I have created an example. We have here some demand that starts on the east of Spain in the region of Barcelona, and the final destination is the west of Spain in the north there. So importantly, we move from airport to airport demand to region demand. That can be challenging from where we get the data and things like that, but that's the starting point, that we are looking into total mobility in a door-to-door perspective. Then we provide a set of pathfinding algorithms to try to find alternatives for those passengers given the infrastructure and the schedules. So for example, someone is able to fly from Barcelona airport to those 3 airports in the region with a direct flight. And as you can see, some of them may even be outside the region of destination just because by access and egress, like getting a car or a bus, they can still reach their final destination. You can also have alternatives where you have connecting flights, like for example, connecting in Madrid or connecting in Seville or even in Alicante. And we look also into alternatives from a rail perspective. So in this case, you start in Barcelona railway station and you try to reach either A Coruña or Santiago, which are the target destinations in that region from a rail perspective. And you can see that you may need to do some changes on the train. Or you can even have a multimodal journey where you have first a train, a high-speed train to Madrid, and then you get a flight. So the machinery that we have created allows you to compute all these different alternatives and estimate for each one of them what is the total door-to-door time, the cost, and the emissions. And based on this, then we do some clustering analysis to remove alternatives that don't make sense from a passenger perspective. So in this case, we end up with 13 itineraries and 3 options, 2 by air, direct or indirect, 1 multimodal, and 1 just by rail. Then we have a set of logit models to be able to disaggregate the demand into different alternatives, into these different clusters. These weights of these logit models are also provided as open source, so you can play with them. And finally, we do the disaggregation of the demand, so what people would like to do, into the capacity of the systems, how many seats there are on the trains, how many seats there are on the flights. So we can do the analysis in terms of capacity demand imbalance, for example. And because it's very low level, because we have all the different alternatives for the different passengers, then we can compute a lot of different metrics, right? We can focus into regions, we can focus into infrastructure, into operators, or very crucially into the passenger experience, like for example, buffers or total traveling time. Then we can evaluate the mobility considering changes to the system, like for example, having newer schedules or having different policies that will have an impact either on the schedules or on the cost or on the emissions. We can do changes in the infrastructure by modeling, for example, shorter minimum connecting times, because we can assume some type of shuttle service between train stations and airports and so on. This, for example, it was done, as I presented before, in Solution 400, where we were re-optimizing the schedules, and then we can evaluate what the impact on those newer schedules are on the passenger mobility. I'm going to show you very quickly a few examples. Here we have 3 different policy packages. The third one, 00, is just as normal day operations. We don't do anything particular. In number 10, what we did is we call it incentivize, because we apply a tax on CO2, and we reduce the minimum connecting times between flights and trains because we assume that passengers were able to do that connection in a smoother, integrated way. And finally, in 20, we added on top of that a short-haul flight ban, where we just removed all the flights where there was an alternative by train on less than 2.5 hours, which mainly is these odd pairs that you can see here. So of course, this is just a what if, try to test what will happen. It doesn't mean that we should do that, but that's the type of things we can evaluate. So for example, with that consideration, we can assess what is the demand satisfied and the mode usage. For example, 81% of the demand was satisfied by the network in intra-Spain, with a 70% load factor between trains and flights. And we can see how, for example, the demand changes between modes, rail, air, or multimodal, as a function of the different policies that we are applying. Interestingly, when we apply the flight ban, instead of having more multimodality, we mainly have more rail journeys, right? Which is also as expected, but that's the type of thing we can quantify. Then we can analyze which OD pairs or which links are saturated, for example. We can assess what is the total mobility time for giving a region of a starting point to other regions within the analysis that we are doing for different policies or different scenarios. We can look into infrastructure connectivity. In this example, you can see the airport of Valladolid, which is northwest of Madrid. And there on the right-hand side, you can see which are the regions of final destination by people who fly to Valladolid and then get a train to get to those regions based on our model in the baseline scenario. Then we apply a short-haul flight ban, which doesn't affect Valladolid airport, but is banning flights going to Madrid. So then what happens is more people are flying to Valladolid and then getting a train to reach these other regions, where before maybe they were flying to Madrid instead. So we can capture these indirect effects of policies in this case. Finally, the next thing we can do is to evaluate the replanning of networks under disruption. So this is much... we have already the network, and then we update that network because we have big delays, big cancellations, air traffic flow management regulations such as industrial action, closures on train links, and things like that. And we can evaluate how many passengers are being impacted by those type of disruptions and which sort of alternatives exist for them under different policies or different conditions, like with different flexibility that we can do for the rebooking of those passengers. In this example, you see someone going from Barcelona to Cordoba there in the south, and in the original journey they were going to get 2 trains, but then we closed the train link between Barcelona and Madrid, and instead they fly and then they get a train. So that's the type of alternatives we can identify, and being able then to assess from the passengers that will be stranded how many can be rebooked, if they keep the same mode, if they switch mode or not. So that's the type of evaluations we can do also, reusing the same machinery we have developed. Finally, for the tactical evaluation, we can put all this information on the itineraries and the schedules, and we can simulate how they unfold through the day of operations with an agent-based model fast time simulator. And that allows us to do, for example, the evaluation of processes such as fast track at the airport and see how passengers will then miss or not their connection as a function of how efficient that system is tactically. This is also provided as an open source tool. So as a conclusion, MultiModX provides this multimodal performance framework with a passenger-centric focus, a strategic planning of multimodal networks, tactical evaluation, the scheduler to optimize the schedules between flights and trains to make the journeys smoother and more efficient, and also the replanning of the operations taking into account large disruptions. If you are interested from a technical point of view, we develop a technical summary which is less than 40 pages long, which covers all the technicalities of the 3 solutions. And also we developed a white paper which summarizes in a few pages the main findings and provides 7 key messages, right? Suggestions for policy development. And everything is available within the MultiModX website, and also the code for the models is available in GitHub too. So that's it. Thank you.